Hello children, you're welcome to this segment of the program, The Classroom in Your Home. It is mathematics time, and that means it is time to have some fun. I am Uncle Agbaje. Today in mathematics we are moving on to a new topic. We will be studying factors and common factors. But before we begin, we'll look at the correction to the previous homework. In the last class you were asked to evaluate this, to subtract 1011 in base 2 from 1100 in base 000 in base 2, and also to multiply 111 base 2 by 10 base 2. Let's just see how that is done. We begin with the subtraction, and of course we arrange as we normally do in base 10. Now 0 minus 1 is not possible. We can't borrow from here, we can't borrow from here, so we have to come and borrow all the way from here, you see. So we borrow 1, we're left with 0, and then we take that 1 to the other side, we are left with 1. Remember that 10 base 2 minus 1 base 2 is 1 base 2. Now we borrow 1, take it to the other side. Now we have 10 at the ones place, so we can begin to subtract. 10 base 2 minus 1 base 2 is 1 base 2. 1 minus 1 is 0, 1 minus 0 is 1. Now we borrow 1 from here again, and we are left with 0 on this side. So 10 minus 1 in base 2 is 1. And this is our final answer, my friend. Let me just let you see that. I hope you got it right. Good. Now we're to multiply this, and we use the Japanese multiplication method. So we just draw 3 vertical lines for the 1, 1, 1, 1 horizontal line, and then a dashed horizontal line. Now remember that along the horizontal line we'll put zeros, and at the other junctions we put ones. And then we circle diagonally. So at the end here we have 0, at the end here we have 1 plus 0 is 1, 1 plus 0 is 1, and here we have 1. So we read our numbers this way, and our final answer is 1110 in base 2. I'm sure that you got this right, and for that I'm going to celebrate you with a chair. Now moving on to that important work for today. What are our learning objectives? By the end of today you should be able to identify factors of a given number. You should be able to use the divisibility rules to identify numbers that 2 and 5 are a factor of. You should also be able to find the highest common factor of some given number. So you should be able to do these 3 things at the end of the lesson. So let's get right into it. So what exactly are factors to begin with? Factors of a number are numbers that can divide it without leaving any remainder. Factors of a number can divide that number without remainder. For example, 2 can divide 4. So 2 is a factor of 4. That's what we call factor. You say 2 goes in 4 2 times, but the right name is factor. 2 is a factor of 4. Now, 4 is a factor of 12 because I can rearrange 12 in 4s. 4, 4, 4. And I have 4 in 3 places. Automatically, 3 is also a factor of 12 because if 4 is a factor of 12, so you can see 4 squares this way, then 3 is a factor of 12 because like I've arranged 12, 3, 3, 3, 3. So 4 and 3, factors of 12. Now, every number is a factor of itself. I mean, every number can go in itself. 12 can go in 12, 10 can go in 10. So you can arrange every number on a single straight line like this. And 1 is a factor of every number. 1 can go in every number. That's why you see that I can arrange a number with 1 squares horizontally. So I'll take that again. Every number is a factor of itself, so I can arrange it. So you can see if this is 12, then I've arranged it 12 vertically. But if I want to say the factor is 1, then I can arrange 1 squares. So 1 is a factor of every number. These are some of the things that you're already familiar with. We're just learning that the correct name for them is factor. Okay, so now moving on. Let's talk about divisibility rules. I mean, just by looking at a number, how do you determine what is a factor of this number without even dividing yet? Well, we'll look at the divisibility rule for 2. So how do we know that 2 can go in a number? Well, all the numbers that 2 is a factor of, all these numbers end with 2, 4, 6, 8, or 0. So when you see a number that ends with 2, 4, 6, 8, or 0, automatically 2 will go in these numbers. Check out the table of multiples, and you will see that in your multiplications table, all the number that 2 is a factor of will be written under 2. So you have 4, 6, 8, and 10, which ends with 0. 12, which ends with 2. 14, which ends with 4. 16, which ends with 6. 18, which ends with 8. 20, which ends with 0. then 22 which ends with 2, and then you go 4 6 8 0, 2 4 6 8 0. All numbers that end with 2 4 6 8 or 0, all of them 2 is a factor. Okay, so let's check out. 2 is a factor of this number, is 498. No matter how big the number is, 8 ends it. So 2 is a factor of the whole number. 624, 4 ends it. So 2 is a factor of the whole number. 950, 0 ends it. 2 is a factor of 950. 1026, 6 ends it. So 2 is a factor no matter how big it is. Let's check out the divisibility rule for 5. We'll know that 5 is a factor of a number if the number ends with 0 or 5. And this is very intuitive. If we start skip counting, 5, 10, 15, 20, or if we check the table of multiples of 5, you see 5, 10 ends with 0, 5, 0, 5, 0, 5, 0. So automatically, all numbers that 5 is a factor of will end with 0 or 5. Now, keeping this at the back of our mind, it helps us when we want to start dividing numbers, and we'll do a lot of that in finding common factors and highest common factors. So 5 is a factor of these numbers: 95, 370, obviously it ends with 0, 1220, it ends with 0, 1775, it ends with 0, it ends with 5. 5 is in the unit place. So all these numbers, 5 is a factor. Now, I'm going to show you some numbers. You are going to have just, let's say, 10 seconds to tell us which of these numbers is 2 a factor of, or 5 a factor of, or both of them are a factor of. You have to indicate. You have 10 seconds. Begin now. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Of course, you will know that here 5 is a factor because it ends with 5. This one, 2 is a factor, but 5 is not a factor because it ends with 8. Here, this one ends with 0. 2 is a factor. 5 is also a factor. Okay, now this one ends with 6. Only 2 is a factor. Did you get it right? Brilliant one. Now, let's look at what we call common factors. There are 24 squares here. 3 is a factor because I am able to arrange it in 3s. And there is no remainder because obviously it forms a rectangle. Okay, I'm able to arrange them in 3s. And 24 squares, so I use this to represent 24. Now I use this to represent 36. And 3 is also a factor because I'm able to arrange it in 3s. So we say that 3 is a common factor of 24 and 36. 3 is a common factor of 24 and 36 because I can divide them by 3 and there will be no remainder because there's no extra squares. Let's see. What is the common factor here? Count quickly. Yeah, 6 is a common factor of 24 and 36 because now 24, I'm able to rearrange 24 in lines of 6. So 6 in 4 places, that's 24. Now 6 in 1, 2, 3, 4, 5, 6. That is 36. So 6 is also a common factor. It's a factor. When we say common factor, it means it's a factor of 24, it's a factor of 36. Okay. Now, what is the common factor here? Count quickly. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Of course, 12 is a common factor because I'm able to arrange my 24 in 12s. I'm also able to arrange my 36 in 12. This is exactly what we call common factor. And we need common factors a lot in mathematics. When you get a number that can divide this without a remainder and divide another without a remainder, then we say that number is a common factor to both of them. We'll see more of this in subsequent slides. But for now, we want you to look at your table of multiples, your multiplication table, and you're going to look at the factors that are common to 30 and 36. I'll give you 30 seconds for this exercise. Look for the factors that are common to 30 and 36, which is the largest. And I've shown you my own in case you cannot find yours. So just check out the lines that have 30 and 36. The factors are on top. Begin. Alrighty then, have you been able to identify these numbers? Let's take them out. 2, 3, and 6, these are the common factors, because here you see 30 and 36, so that means 6 is common to both of them. Here you see 30 and this is 36, so 2 is common and 3 is common to both of them. And of course, if we extend this further, you will see that we'll have 30 along the line because 30 ends with 0. We'll also see 36 along the line because 36 ends with 6, and both of them, 0 and 6, tells us that 2 is a factor of both of them. So these are the common factors, 2, 3, and 6, but the largest of them is the one that has 6. Okay, so let's now talk about our common factors. With that example we were working with previously, we couldn't go further than 12. 12 is the highest common factor. I mean, we had 6 to be a common factor, we had 3 to be a common factor of 12, of 24 and 36. But then we got to 12 and we couldn't go further. So we said that 12 is the highest common factor. But every time we want to find the highest common factor, we will not need to be drawing squares and rearranging. There's a simpler way to do it in mathematics, so you just pay attention to me. For example, we want to find the highest common factor of 24 and 36. All we need to do is bring 24 and 36, draw a line like so, and now we begin to divide them with the small common factors that we know. Now 24 ends with 4 and 36 ends with 6. And now we know that 2 can go in both of them because numbers that end with 0, 2, 4, 6, 8, and 0, 2 is a factor. So 2 is a factor of this. So we just divide by 2. Put 2 here. 24 divided into 2 is 12. 36 divided into 2 is 18. Now check it again. Can 2 still divide? Of course 2 can divide because this ends with 2 and this ends with 8. Okay, so we divide like so. 2 goes in 12 6 times. 2 goes in 18 9 times. Now can 2 still go in both of them? Obviously 2 can go in this, but 2 cannot go in this. So we can't use 2 anymore because we have to look for a factor that is common to both of them. Now if 2 can't go, what else can go? 3 can go. And 3 goes in 6 2 times. 3 goes in 9 3 times. So now nothing can go again in 2 and 3. Okay, except of course 1, and 1 will not reduce it further. So we say that these are the lowest terms. We'll come back to that. But these are the numbers that we need. These numbers, the common factors that we used to divide. So which one is the highest common factor? Is it 3, 2, or 2? Well, it's none of these. To get the highest common factor, we simply have to multiply all these numbers together, and that is 12. 2 times 2 times 3, you get 12. It's as simple as that. Again, all you have to do is just reduce the numbers using their common factors until you can no longer go further. Then you multiply the numbers that you have used to reduce. Let's check out another example. This one says we should find the highest common factor, which we call HCF, of 60 and 80. So again, we write 60 and 80 beside each other like so. Then we draw this line like so. Then now we observe that both of them end with 0, and that means that 2 can go. So we divide them into 2. Now we have 30 and 40. Now both of them still end with 0, so 2 can still go. So we divide them into 2. Okay, 15 and 20. But now 2 can go here obviously because it ends with 0, but 2 cannot go here. Now we observe that 5 can go in both of them because obviously this ends with 0 and this ends with 5. So 5 is a common factor. Then we reduce them. 5 goes in 15 3 times. 5 goes in 24 times. Now, there is no other common factor. So we say, okay, you know what, this is the lowest we can go. We call them the lowest terms. But we need to multiply this to get the highest common factor. And that is simply 2 times 2 times 5. 2 times 2 is 4. 4 times 5 is 20. Let's check out the last example. This example says we should find the highest common factor of 27, 45, and 48. 3 numbers, no problem. We just do it the same way. Arrange the numbers beside each other like so. Draw the lines like so. And then we look for common factors. Now, 2 cannot go in any of these numbers anyway. So it's not that every time you want to do highest common factors, you start using 2. That's why I taught you the divisibility rule for 2. You have to check the end to see if 2 can go. And 2 cannot go here because this is not 0, 2, 4, 6, or 8. This is not 0, 2, 4, 6, or 8. But 2 can go here. But since 2 cannot go in all of them at the same time, we don't use 2. 3 will go. And 3 goes in 27 9 times. 3 goes in 45 15 times. 3 goes in 48 16 times. Now check this and you see that nothing else can go again. 3 can go. Nothing else can go. So this is the lowest term. And obviously, so what do we do here? The highest common factor is just what is there, and that is 3. Don't worry, I'm not going to give you something as tough as this for your activity. That will be for the homework. But for now, take this. You have to find the highest common factor of 18, 24, and 30. You have 1 minute, begin. Alrighty then, have you gotten your final answer? Let's see how it's done. Of course, we arrange 18, 24, and 30 like so. And then, what is that number that can go in all of them? 2. Good job, you. So 2 can go because this ends with 8, this ends with 4, and this ends with 0. Okay, so 2 goes in 18 9 times, 2 goes in 24 12 times, 2 goes in 30 15 times. It's like saying divide them into 2. Alright, so now 2 cannot go anymore because this one just spoils the show. Okay, so we have to use another number. Now we discover that 3 can go in all of them. So 3 goes in 9 3 times, 3 goes in 12 4 times, 3 goes in 5 15 times. But what is that number that can go in all these numbers, 3, 4, and 5? Except 1, nothing else. And 1 does not reduce each further. So we stop here, we say these are the lowest terms, and we multiply 2 by 3. Our highest common factor is simply 6. So, did you get the majority of what we've been trying to say? To find the highest common factor of a set of numbers, reduce them with small common factors until you can no longer go further. You say you have gotten to the lowest terms. Then, the common factors that you have used to reduce them, you multiply them together and you get your highest common factor. Now note that in reducing them, you have to be very, very careful. Okay? Okay, so let me give you the assignment for today. You have to find the highest common factor of the following set of numbers: 24, 32, and 40, 45, 60, and 90, 24, 36, and 42, 48, 60, and 72. I believe you should have fun doing this. You can also test your knowledge of what you have gained by taking the online assessment. We'll give the link later in the program. Now it's time to hand you over to Uncle Popo for the general studies lesson. Till I come your way in the next class, remain wonderful mathemagicians.